many reviewed journals and acted as session chair and technical program committee member of national and international conferences. His work has been profiled broadly, such as audio, speech, and image processing, deep learning, pattern recognition, and neural network. His research interests includes big data, audio and speech processing, soft computing, and computational modeling. He has acquired lifetime membership in ISTE, IAENG, IACSIT, and SDRA. I am very glad to welcome such a noble vice man to address the gathering with his vibrant presentation on machine learning techniques in speech processing. Welcome you, sir.
Thank you for nice introduction. Machine learning techniques to speech processing. So here I am going to give overview or introduction about these things. Here I have treated 4 parts. First, introduction about the speech processing and model, how to use speech to particular model. And the next part is machine learning techniques. Machine learning techniques, basics of machine learning techniques. What are the mathematical model and statistical model used to particular machine learning. Next part is machine learning. And the last one is what are the performance metrics available in machine learning and deep learning. And if time permits, I will give you some implementation of this speech processing. So these are topics I am going to deliver. This artificial intelligence, machine learning, deep learning, classification, clustering. So these things are the basic statistical model. Next, in the regression model, K means Gaussian mixture model, support vector vision. So this is the techniques used to speech processing, audio processing, or general machine learning methods. And the final, so this is Google, Alexa, Siri, and Cortana. So these things they are using in speech processing. So these are the working with the systems. First one is voice activity detection. So voice activity detection or speech means it detects silence and non-silence. If I am speaking, activity. So voice is separate. So here they detect the where is silence. So in research they are saying silence, non-silence. Silence means in between voice and the activity. In between, I will show you the example of that. So these systems are the people are working and already worked. Next is speaker segmentation, emotion recognition. Many people are working with emotional recognition. The mood of the person. The person is who's happy, unhappy, sad. So based on our word, our speech, recognize the now he is happy, sad. So this emotion recognition it will based on speech as well as image. So based on image also it will recognize the emotion. Speech to speech transformation, keyword detection. like Google search engine, audio indexing and retrieval, audio segmentation, and the classification of audio. So and many more. So all these AI systems are the people are looking. So it's everything based on the frequency. So all the process based on frequency. So this is the pre-process of speech processing. So we have to give the speech signal, and here, so in between this is a signal. So there is a no signal. It is a silent one. Here. So as already I told you, so this is a speech part. So in between there is a small gap. So that is a silence one. So this one is speech detection or voice detection system. So these are general feature extraction method for speech audio signals, speech audio and music, right? So all those things. So feature extraction methods. First one is short term energy, zero crossing rate, auto conversion, short term Fourier transform, linear prediction coefficients, efficiency, and this is normal feature extraction methods of speech and audio signal. So this is the features available in that speech or audio signal. Duration of the speech and the pitch, the speech, high pitch, low pitch, rhythm, intonation, pitch counter, loudness, voice quality, positive. So this is the features available in the some features available in the speech and the audio. So we extract these features using this model, these methods. So this is the signal, example signals. So the people commonly use machine learning method model. So many models are there. Hidden Markov model, Hasid mixer model, artificial intelligence, gaming algorithm. So some deep learning algorithms. Yes. How we will implement the speech processing or audio processing? First, we have to collect the data from some other source, from internet or real-time data. So after collecting, we have to do that prerequisites, that is filtering method. We have to apply the filter method, some other filter method, bandpass filter, some other filters are there. So after filtering, extract features from the audio signal. Already explained that features. The features may be vary, depends on the data, what we use the data. And after collecting that feature extraction, next one is we select the best or optimum feature, which feature is optimum and best. Then we have to apply that these features to model, that is the machine learning model. Yes, choose the model and build the architecture, and finally we compile and we evaluate that. So here there are normally in machine learning two parts. One is training part, another one is the testing part. So we that is we take the training percentage something, testing percentage something. Normally 80-20, 80 is training and 20 is training and 80 is testing, or 50-50 or 40-60, depends. Yes, so this is the flow of, as I already told you, the flow of the audio or speech processing. We are giving the speech signal, this signal, it converts to the pre-processing. So here raw data, we collect the raw data, the original speech, the raw that converted into binary and binary format, that is 0 1 format, and then we giving the pre-processing. First we convert to 0 1, right? So let me prove that everything processed by the 0 and 1. The system will accept 0 and 1. Next, feature extraction. Feature selection, that is articles. There is some methods are there, article methods, and the classification models, and what are the classes, which classes shown. So these things are the basic or introduction about the speech processing and audio signals. Next, machine learning. So the machine learning, the concept of machine learning is improving with previous experience at some task. So why machine learning? So suppose if we take Google search engine, 10 years before, how would they retrieve the data, and now how it is retrieve the data. So suppose we are giving some word, immediately we give the answer, that is keyword, filtering the method. So suppose, for example, if you take email, if you take email, so if you are giving some input, it will retrieve the data. That is customized. And one more thing is handwritten recognition. So ML applications, image processing, these are some ML applications are used. Face recognition, e-commerce, general experience. These algorithms, some algorithms to implement that machine learning. So samples, now we are all using Python, so very good language. So voice technologies were used, the percentage, the globally here how much they are using this voice techniques in the globally. Yes, next artificial intelligence, machine learning. What is artificial intelligence? Machine learning and deep learning. So artificial intelligence is like a robot. So it's a creating intelligent machine that work and act like a human. So machine learning is a part of artificial intelligence, which implement some statistical methods. So next one is the deep learning. Deep learning is subset of machine learning. Here the difference is the increase the layers, the increase the number of layers to work out good result. So this is general binary classification, and another one is multi-classification using the data. The classification and the clustering is a supervised method. Clustering is a supervised method. In machine learning, two methods are there for this method. In machine learning, two methods are there for this supervised, and another one is unsupervised. The classification is yes. So this is also based on the features that group the data. The clustering techniques are k-means, expectation maximization algorithm, Austin Wilson model, and auto-associative neural network. So these are unsupervised methods in machine learning techniques. So these are supervised method. Yes. So already the people know mean and covariance. If we are going to design the model, that is machine learning model, we should know that these the basic piece of the statistical method. So these are our data. The sample data of height. So finding the mean and finding mean and variance. So here the formula of finding mean is mu and sigma the variance is sigma. So mean and the variance are scalar value. So next one is mean vector and covariance. So here, if you are giving a height, it will predict the weight of that particular person. Based on this calculation, I will show you later. So in mean vector and covariance, here, if you are giving a height and vector, it will show his male or female, depends. So mean vector, mean the formula for mean vector, and this is covariance. So mean vector and covariance are more than one variable, that is vectors. Here scalar. Next important is the normalization. So we have normalized the data before the proceed further. The value should be -1 to plus 1. So normalization formula, y is equal to y max minus y min divided by x max minus x min, and x minus x min plus y min. So this is the formula for data normalization. So this normalization is normalization or filter, everything is clean the data. If we give the data to model, first we clean that data. So after that, it will get good result. So that is why the normalization done. And univariate Quasi distribution. Right. So here there are two hyperplane. One is linearly separable. This is inseparable problem. So linearly separable, we can separate easily. Here we underwent to that separate. So we will do some operation. After that operation, in the sense of some mathematical calculation, we convert to like this. So this is linearly separable problem and linearly inseparable problems. Here we add some high dimension values and we convert to like this. So altogether we have to use that model. So the way we have to use that SVM model something. So next recursion, the classification and the clustering. So the recursion is predict continuous value output. The classification is it predict that discrete number of value, and the clustering is that is the partition in that data. So here we get the output, numerical output instead of labeling. Here we are using label. What is a label? That label given in the doing the training part. So here there is total labeling in this clustering. So recursion model. So recursion, there are two type of recursion. One is linear recursion, another one is artistic recursion. So linear recursion, it is a simple like straight line equation. A simple recursion model that gives a straight line relationship between two variables is called linear recursion.
So x1, x2, x3, xpr, that is input variable. The output is here there is a number of input variable. Here the single output, we will get a single output. And the recursion model includes two variables. One is independent and one is dependent variable. So linear recursion. So it is simple linear recursion. Our simple straight-line equation. The basic estimation is independent variable provide the basis of estimation. It is predictor variable, and dependent variable is variable being predictor or estimator. So here the y is dependent variable, and a is constant term or variables. This is slope, b is a slope, x is independent variable. So here there is some formula is there, the equation is there. Single input variable, two input variable, and d input variable. There is number of variable. So here the plotting of one-dimensional linear regression equation. Is the example of linear regression model. Here the weight of person predicted based on the height. So suppose here these are on height, that is 10 value there. So here the weight of that value. So first we train these things. First train these things. Example. So after during test we have to give some height value. It will predict what is the weight of that particular person. So likewise we calculate. So here some calculation. This calculation is used for this linear regression model. The equation of the linear regression of t 75 So likewise it will calculate this linear regression equation. So here in linear regression equation, one input, one output, that is a single output, and also in linear regression, it's the output is exit from this J3. I will show you the example. Yes, next one is logistic regression. Here we are giving more than one input. But we will get the single output. So this is the model of logistic regression. So linear model is exit from this model, but in logistic regression lies in the model. See. So this curve is logistic, the straight line is linear. The beyond that model. Yes. So logistic, it will give the output, the polynomial, multinomial, ordinal. So here the output is either 0 or 1, or will lose, pass or fail, or like this, or some other output like this is A, B, C, like that, and more than 3 also we get the output. Yes, so this is the Western the representation of linear and arithmetic regression. So the predictor exceed predictor y can exceed 0 and 1 region, and in this predictor lies in that one